Ladies and gentlemen, we're live. Welcome to Global Online Meetup for Rancher Desktop. Now, I've been extremely excited about this event, and we're going to give it a few moments to allow people to stagger in for this event and just catch up. My guest is here. He was on camera a minute ago, and now he's back. The gentleman who will be talking, actually, he's been doing a lot of talking lately. And I don't think there's anything that we can do to shut him up, but he is here. He's going to talk about Rancher Desktop. He is going to walk us through what it is, what problems it solves in the ecosystem. Ladies and gentlemen, Matt Farina. Matt, welcome. And you're on mute.
I am, and the mute button went off screen. Hello, everyone. Thanks for coming out to hear me talk about Rancher Desktop today.
Now, we're going to get some housekeeping out of the way. We are using Crowdcast. Crowdcast is our platform of choice. You have a handful of buttons. You have a chat that I see is already active. You'll see me look up and look at what's going on in chat. Say something nice. If you feel comfortable, say where you're from. I like to tell my kids who we're talking to around the world. We also have a poll. I'll throw a couple of those out there when Matt's in the middle of talking. So look out for those particular polls. And then we have a way to ask questions and upvote and downvote questions. So ask your questions. This is interactive, right? So as Matt's talking, if a good question comes in, I look up, I see it, I will see it because it gets this big flash on my screen that there's a question. Let us know, and I will interrupt him and get those questions answered as we're going. Now, if you have a super specific question that's a little off topic, we'll probably table that and we'll come back to it at some other time. But if it's relevant to Rancher Desktop and what we're talking about, please ask those questions. Lastly, right below, there's like a little green button somewhere down there. That green button, you can join the SUSE and Rancher community. You can find out what's going on with SUSE and Rancher, what's going on in the ecosystem at whole. We keep up with the pulse of what's going on. You'll hear us talk about some of these products and projects as they're coming. We have a lot of events, and we have a lot of educational sessions that you can join, like Up and Running with K3S, Up and Running with Rancher. We even have an introduction to Kubernetes course for those who are just not knowing what the hell Kubernetes actually is. We can explain that. The community is there for it. So without further ado, I'm going to let Matt get his screen share on.
All right, I will share my screen here. And can you all see my screen?
We can. If we see your Rancher Desktop icon and a web browser, we do not see your slides.
All right, can you see my slides?
They look beautiful.
All right, so I'll actually step back for a minute here. So I think we've gone through all of this, right?
Yeah.
And so here's kind of what I was going to go through today, kind of the objectives and everything. What is Rancher Desktop? Why did we create it? How did we get to where we are? And then I had a bunch of demos I was going to go through of different things you can do with Rancher Desktop to try to show off what's going on and what do you got. And so I've come up with 3 different situations I'll kind of walk through, hopefully to look at the kinds of real world situations you all would end up going through and needing to deal with and to consider. But before that, what is Rancher Desktop and how did we get here? And it all started a while ago when we were talking about what is Kubernetes on the desktop? What do people use and what do they need and why do they need it? And, it raised some questions, right? Like, what do people think? Do they think of Kind, Kubernetes, and Docker? Kind was originally created for testing Kubernetes itself. Minikube was the Kubernetes project for kind of running it yourself, but they didn't really work for testing Kubernetes itself. So they came up with Kind. And Kind is Kubernetes in Docker. And people started picking it up to use it in CI/CD and other places because that's where the Kubernetes project used it. And then some people wanted to use it on the desktop. Maybe you think of Minikube, right? I just said it's what it replaces. It's another Kubernetes project. It's the longest active Kubernetes dev tool. Out of the box, you use Docker to spin up your Kubernetes environments, but it can use VMs as well. And that's another tool, that you can use. Maybe you think of K3S and K3D, which lets you run K3S inside of Docker. And at this point, you might be seeing a theme here. When you interact with all of these tools natively, you're dealing with terminal windows, and the primary supported is through Docker itself. And so there's kind of these themes going on here with the tools so far. And so lots of people want graphical tools. They want GUIs. GUIs are more discoverable of your configuration and your features. You can spend more time focusing on what you need to deal with. And so, of course, then you've got to talk about things like Docker Desktop, because Docker Desktop has Kubernetes as well. And with Docker Desktop, it's not open source. It's coupled to Docker services. And the thing that caught my attention was that it is coupled to the version of Kubernetes they ship. And for me, that's always been a problem. You get an environment and you get this one version of Kubernetes. And the reason for that is there are so many versions of Kubernetes out there in use, right? I kind of talk about it like it's Android versions, right? Here's a screenshot of some statistics on Android, and you see all these different versions in use. In fact, the latest version in Android's case doesn't even have a major market share. And that's kind of how it is with Kubernetes. You go back 2 minor versions, and that's where you hope a lot of people are. But there's this huge scattering. And I wish there was some data I could put up somewhere on this. Old surveys and things that are public show this, and we know this from talking to folks, but there's so many versions of Kubernetes in use, and there's just differences between versions of Kubernetes that you might use in, just minor versions. And so if you test everything in your local environment and it's one version of Kubernetes and then you switch to another, things might fall over and break. In fact, I've had that where things just kind of fall over and they don't work right because there's some nuanced change. I know when Kubernetes has dropped support for beta APIs, that's always caused a lot of problems when people start testing things and then their local environment break or they upgrade. And how do you deal with all of this version sprawl and actually working locally with what people are actually going to work with? And so just having one version doesn't work. It came to the conclusions there were no great open source Kubernetes desktop applications. And SUSE is an open source company. We like open source stuff. And we wanted this. We wanted to see this. The last thing I can remember is a project called Kube Solo. It was on Mac. It lets you do a lot of these things, provided user interfaces. I really like this. I actually used it. But it's been archived and hasn't been updated or worked on in years. And it provided you that desktop experience where you could discover things. And with nothing there like that, it was kind of inspiring to say, let's go create something. And that's where Ranger Desktop came from. We originally focused on how do we bring Kubernetes into the world as a desktop app and just make it easy for people to work with. So you don't have to jump into the terminal, learn lots of switches, try to discover what are the switches and how things work. In a GUI, you can just look through the screens. You can see, here's the settings. Here's what I can generally do and make those changes. What you can do with it is really discoverable. And that's important when you're trying to figure something out. And so we want to figure out how do we do this and make it work well in a lightweight, performant manner on your system. And so that's where Ranger Desktop came into play. That was its original inspiration here. And these days, we've expanded from that original Mac environment where it started, where we have Mac, we have Windows, and we have Linux. And so you can run it as a desktop application in all 3 places. And we thought this was important because there's a lot of people who have Linux on the desktop, a whole lot of people who are using Windows as their primary development environment, and a lot of people on Mac as well, who all want to deal with containers and Kubernetes. And so getting it in all 3 places was important to us. And it's really easy to get. If you haven't already installed it, you can go to rancherdesktop.io, scroll down a little bit, and we've got places for you to either download it or install it. On Mac, it depends whether you're on Intel or Apple Silicon for your chip. And on Linux, because we don't have a download for Linux, because you might want to install it as an RPM or a Debian package. We've got some different ways you can do it that fit for Linux. So we give you directions on how to install it on Linux. So that way you can install it with your preferred means. All right. And so here's a little bit of the architecture, and I'll walk through how this works, right? So you see Rancher Desktop up there. And Rancher Desktop is an Electron app that bundles a bunch of other utilities. We have Nerdy Control, which is a Docker-compatible CLI that works with the Containerd engine. We've got kubectl, which is your Kubernetes command line, and Helm, the package manager. And then we have the Docker CLI, which works with Dockerd as that container runtime. And you're only going to end up working with the Docker CLI or Nerdy Control, one or the other, dependent on what you're using. So Nerdy Control works with Containerd, the Docker CLI with Dockerd. Then what Rancher Desktop does is it spins up a virtual machine. And on Mac and Linux, that virtual machine is spun up using QEMU through a project called Lima, which is another open source project that lets you, that kind of helps us with this. It lets us do containerd and those kinds of things really well. And then inside of that environment, we spin up K3s as our Kubernetes distro. We chose K3s because it's really lightweight. You have less system services running, and it uses up less of your system resources on your local machine. So you have more of that to use for your own stuff you're working on, your own containers, that kind of thing. Then over on Windows, we wanted to not just have Windows professional users have it or Windows Server users have it. We wanted every Windows user to have it. So that way, if somebody wanted to go home and work on their Windows home machine and do something with containers, they could do it there. And in order to be able to create and manage virtual machines to run Linux, we went with Windows Subsystem for Linux because that works on every distro of Windows. While actually creating your own VMs is kind of a problematic thing over there with Windows. So Windows Subsystem for Linux is kind of our wrapping technology where we create distros in there. And of course, it's containerd or Dockerd, and then K3s on top of that in order to get that environment going. And I know some folks may be wondering on Linux, why do you wrap it in a virtual machine? And when we went after Linux, we had some questions about it. And I know I originally thought, we'll just install it on the base system if we do it on Linux. But it turns out a lot of people like that ability to just blow away their environment at the click of a button and not have it contaminate their host system. Or they like the ability to constrain how many system resources their container environment gets a chance to use, because you don't want something running away on it. And next thing you know, it's taken over the whole system and your Linux desktop can't do anything. And so the ability to blow things away, to constrain that environment, to not tamper with your base system really drew people to ask for Linux being wrapped like this. And that's on top of any security considerations people might have. And so this is kind of the layout for how Rancher Desktop works. We have an application that goes off and it spins off other processes to do other things to create and manage that environment for you. Now, we do have some design goals here that really get to the core of what we were thinking early on and as things changed. And I'll touch on that near the end of the goals here. We want you to choose the version you want. So any version of K3s that's been out, you can use right there. And the whole idea is map it to your version that you're using in production or your development environment or where your customer is going to be doing things or your end user, or test with different versions of the environment, because the version in Kubernetes matters. So let's make it easy to do, right? We want a seamless upgrade. We want you to be able to test what is it like for your workloads when Kubernetes is upgraded. There are a lot of people out there who can be scared that, oh no, if I upgrade Kubernetes, I'm going to break my environment. I don't know what gets touched or how it gets touched. How are the Kubernetes manifests going to handle this in controllers? We want, you can't replace all of the testing around that, but you can do a lot of it by allowing you to upgrade your Kubernetes environment and see what happens with your workloads. See how the Kubernetes controllers and APIs and everything else work with this through that upgrade. And so we provide a way to test that, and I'll demonstrate that today. We wanted to leverage upstream projects. We are interested in that experience of making everything easy. We're not interested in recreating the wheel. So those things, K3s, containerd, Dockerd through the Moby project, all of these things, we want to bundle together in a really easy to use way so that it's really not a problem here, right? Leverage those secure upstream projects.
So with that being said, there's a question that came in through the community. Is there any plan for Podman support, since you talked about Moby and containerd?
We've talked about it, and we've built a system to be, I think, pluggable enough to support that. I think it's pluggable enough we could possibly support that. The real issue is going to be, do we get a call for it? Do we have enough people who are interested in Podman support that it becomes something that we want to incorporate? And at this point, we haven't really gotten a call. We've got a bunch of other things where people have asked about and other ideas we've got about creating a great user experience. But as far as people showing up saying, we really want you to support Podman as another container engine, that just hasn't happened yet. Our architecture allows us to extend to add another container runtime. And some of the stuff we've talked about as internal refactorings will actually make that easier for us to do. But it's not something we've heard a call for yet. So if people are really interested in Podman support, I would suggest filing an issue and then getting other people to pile on that issue to say, yes, we really want it, and here's why we want it, because then that will let us know, okay, people are interested in this. Let's talk about how that would work into what we're working on. Does that answer your question, Robert? Do you think that answers it?
I believe that answers the question. It's like any other, open source project, right? So we don't know what exactly to support or add to something unless the community gives us that feedback. And I think that's what you're saying there.
Yeah. And one of the things that we've done and we're trying to improve upon is those areas where you could have more than one solution for something. Once we see there's a need for more than one solution or a desire, we try to make that part of the system pluggable. So that way you can plug in different things and it becomes a little bit easier. We've got interfaces defined in our code. And then, when you switch like between different environments, whether it's Lima or the Windows environment or between Dockerd and Containerd, we've created interfaces and then things that, fill out that interface that perform the functionality that's needed to make everything come together. And so we've tried to make it extensible so we could add more things as possible. That's just part of our architectural design. Another thing, easy installation. I already showed you how easy it is, that you can just go download it. With a Windows, there's an installer. With Mac, you just kind of drag and drop it into applications, just like you would anything else. Our goal is to fit in with that easy installation of a desktop application. We also want it to be completely open source. No magic, nothing hidden behind a proprietary shield or anything like that. SUSE is an open source company. Everything we do is pretty much open source and it's out there. From the Linux distributions through Rancher to everything else, we try to make the source out there, and that's just generally how we operate as a business. So this is nothing new or surprising for us, but everything's completely open source. And then that container tool chain, to build, push, pull, and run, with images and then run containers. One of the things that we found is after we had done Kubernetes and we had Kubernetes up and running, right after that, people started saying, hey, I also want to be able to, build my images. I'm going to work with container registries. I'm working on this container and I want to test that container before I combine it with my Kubernetes stuff to see how it's working much more quickly rather than having to rebuild it and test it with Kubernetes. How can I do that? And one of the key things that caught our attention was, how can I build images and test them without ever needing to push them to a registry and then re-pull them into Kubernetes? How can that kind of situation work? And in order to make that work, we had to bring in other technologies. We originally brought in nerdy control and tied it to Containerd. But then we found there were features in nerdy control which hadn't been implemented yet by that community that people kind of expected out of the Docker CLI. You couldn't just map an alias, the nerdy control or Docker to nerdy control and have everything work, because there were features that just weren't there yet. And we got this call and this question for, we want those extra features, which is what ultimately led us to incorporate the Docker CLI and Dockerd through the Moby project in here so that people could go ahead and use those extra features. And so now we support those different environments. And our goal is to have that container tool chain, right? We are a Kubernetes company and we do a lot with containers, but we want to make sure that you're able to build and work, especially people who are doing applications and how do I construct that? Or how do I onboard a third-party application like a database and wrap it in a container and test it? We want to make sure that experience is great for you in a desktop app. All right. So the next thing we're going to do, I guess, is go to the demo here, where I'm going to just kind of show off some of the different things going on. So I hope you can all see my desktop here. And to show this off, what I have is I have Rancher desktop running here. I've got it up and running, and you can see it. And I'm running Dockerd, Moby in this case, as my background.
Yeah, it's a little small and hard to read, Matt. So we're gonna have to just a little more.
Thank you.
Oh,
that
perfect.
Better?
Yes, thank you.
Woo. All right. And so I can just go run something like Docker images, and you can see the images my Docker environment has. I wiped it out and I had a pretty simple environment here. You can see things involved with Rancher. And this is stuff that we're using just in that K3S environment. And then you can see the SUSE one, which I'll get to in a minute. I pre-pulled it to help with the demo, but we've got a basic environment here, right? And so if I go Docker PS, I can see the things running in my Kubernetes cluster because they're containers running in that environment. And you can do things like Helm, and you see I've got nothing installed here. So I have this thing, and I've called it Hello World this time around. And I'm not making you all suffer through my last demos. I would rickroll people, but I'm not doing that this time. Make this a little bigger. All right. And so I've got a Helm chart here for an application for my Hello World application. So we'll do Helm. We'll just go ahead and install this chart. And that's going to go ahead and bring up an application here. Let's see, what do we... And we'll see if it's getting going yet. And we can see it's up and running. And so here I can go ahead and grab this. And we'll see what this application looks like here, right? So I can go ahead and open it in a browser. So here's my Hello World app. And in this case, it says Hello Rancher Desktop. Well, that's not really what I wanted. I wanted it to say Hello World. So let's go look at what it would be like to kind of edit this application, make a change, and test some stuff here, right? So in this case, I'll leave this running for now. And I'm going to go over here. And so I've got this code here, right? You can see I've got the code here. And I want to go ahead and edit it. So I'm going to go ahead and open it up in Visual Studio Code. I'm just going to go ahead and open this thing up. Now it's asking me here about dev containers. And do I want to open it up in a dev container? So I'm going to go ahead and open it up in a dev container. Now, if you don't know, a dev container in Visual Studio Code is a way where your whole environment is wrapped inside of a container, and you do your development in that container. So you can have the tools you want, you can have everything you need. And so like on Mac, and since I'm running this on Linux, running it in a container means I can actually test inside of that Linux container and see what it's going to go look like. Now, one of the things it's taking a moment for here is this was my first time because I wiped out my environment. It actually had to go ahead and rebuild that dev container. And in this case, the dev container, it's a really simple configuration that just says use a Docker file to create it. And the Docker file is pretty simple. I grabbed that image that I showed you earlier, registry, SUSE.com, BCI, Golang. What this is at SUSE, we have these base container images. And SUSE Sleep, one of our Linux distros here, is a pretty secure, or I should say really secure environment where we've done all kinds of stuff around security. As soon as, security updates come out, it's updated, and we've built container images around it. Some of them are very empty and sparse, which is what you'd want if you didn't have anything. Other times they'll have a language runtime or a language environment. In this case, we've got the Go environment. So it's a very slim environment with Go. And then I used a package manager to install a few things that I need there. tar and gzip are for it to be able to work with Visual Studio Code containers, and then Git for me to work in that environment. And as you'll see, this terminal here is running inside the container. And so that's kind of what this is. And so I've got a dev container here. But we're going to go over here and actually look at the code. And the code, and by the way, this Docker file that I run for the dev container is different than the one that I would use if I were actually going to build it.
Yep.
Yeah.
Can we hit Apple Plus a couple times and make that your
You
ID?
are.
Yeah.
Yep. Here we go.
Feel free to full screen it too if you want.
All right. We'll go bigger. Sorry about my size. Thanks for pointing it out. Mm-hmm. So my Docker file that I would use to actually build this into something, and you'll see more of that in a minute, is a little different. I use a build image, which uses that same image here that I'm using in my dev container. So I know it'll be built the same way that I test it. And we actually build it, and then we put it into a Scratch container. Because with Go, you can build your stuff in such a way that you don't actually need an environment other than the kernel. And so in this case, I'm using a Scratch container so I can get it down as small as possible. But I'll show you a little bit more of that in a minute. But that's the reason I pulled the image. So let's go over here and we're going to make a change to this and test it out. So we're going to change this to hello world. And we'll go ahead and save it. Now I want to test this, right? And this application, I did a little thing. I added a debug flag so that way I could see it. And for the logging of the debug flag, I'm using a project that lets me log. It actually provides an interface that works with lots of logging libraries. But out of the box, it just works with the standard library. And so we're going to go test this. So we'll go run this application just as something in Go. And the first thing it does is it's going to go download the dependency, then start things up. Now it tells me, hey, we've got this thing going. Do you want to open it in a browser? Because what's running in a container is now port forwarded out, and I can go open it in a browser and I can see what happens. And it says, hello world. This is great. I've changed my application. And in debug mode in here, I can see a lot of other information because in debug mode, it tells me what the request looked like. And so I can see more of that information. And you won't get that in a build, but I can test that here and I can work on it. I could iterate on it and work on that stuff now. So now I've got this thing going and things seem to work here and I'm happy with the change. So I'm going to exit out of here and I'm going to go back to my terminal, right? So I've got this, but I need to build it, right? So here we got it and I've got my changes, but I want to actually test that out with Kubernetes. So I'm going to go ahead and I'm going to build it. And my version in Kubernetes right now is using the version of this that's tagged at 0.1.0. So I'm going to test out this new build at 0.2.0 with my differences. And so here I'm going to do a Docker build. I'm going to tag it with that so I can test it in my Kubernetes environment. And I'm just going to build that current one. Now it's walking through the steps and it's actually building it and it'll use cache layers where it can. And so right now it's downloading go mod download downloads that one dependency and it's copying everything in. Now it's building the image or building the binary and it does it with cgo disabled. So it works well without the system libraries. And then it turned everything into that container. Now let's go look at Docker images here. One of the neat things is that container it was built on because it had the Golang stuff is 1.04 gigs in size because it had all the Go build utilities. But by copying that over to a Scratch container, I shrunk it down to 6.12 megs. And so you can see a big difference here when you get rid of all those extra things out there. And so I went ahead and I shrunk it down. But now we want to see what does that look like in Helm? What is that difference here? So, or in Kubernetes. So we'll go ahead and do a Helm upgrade. So I'm telling it for the image to use another tag. Now I haven't pushed it or pulled it anywhere, but it's just available in Docker because it's one of the images. So I'm going to go ahead and set that, my image tag, to something else. And if we come, we'll go see what happened with Kubernetes. And we're actually going to see the new thing is already up and running, just a few seconds old. That's because it didn't have to do anything with the image. And so we'll go ahead and just bring that back over in a port forwarding manner. And we can come back here and refresh and hello world, it worked. All of it was done locally. I used a dev container for my build environment. And all of that kind of worked and flowed very nicely just as an environment. And I know it's a simple example with hello world, but this expands to other examples, other languages. You can do it with Node, Python, all kinds of different languages this works for. And so here we upgraded it. Now that I'm happy with it, I could push the image, I could upgrade my charts, I could do all of those things. And all of this stuff, examples here, are available on GitHub right now. So if you wanted to go poke at the code, they are up on GitHub, both the hello world and the chart, if you wanted to see this stuff for yourself. And you can just go over to my username on GitHub, which is my same handle everywhere, Matt Farina. But the next thing I wanted to show off is, well, what happens when we upgrade this environment? What does that look like? And here I've got Kubernetes 121.9 running. And it's okay. What happens if we upgrade to Kubernetes 122? What happens with this application that's running in this environment? And so to do that, it's actually pretty simple. I can just go select a newer version. And what it does is it's going to warn me that it's going to upgrade Kubernetes. Do I want to proceed? And the answer to that, I'll say, okay, yeah. And so it's going to go and shut down Kubernetes. Then it is going to restart things. Now, if it didn't have that newer version of Kubernetes, it would download it, because when it only downloads the versions you want to use, and then it caches them locally. So if you're going to change versions, you do need to make sure you're connected to the network. In this case, I had everything cached, so it's ready to go. And so now it's started everything up. The VM's running, Kubernetes is running. It waited for the API, waited for the services, everything to come up. Now everything's back online. You'll notice that the port forward stopped working, and that's because the connection with Kubernetes was broken, and so that happened. But I should be able to do this again, and I just restart it, and then we can come back over here and refresh it, and we can see everything's working, because everything came up just fine. And that's a way to test for upgrades with Kubernetes, just to see how the environment works. It's as simple as changing the version there. We can't, however, go backwards. So if I went back to 121.9, you're going to see that it's going to reset your Kubernetes environment. And the reason it resets your Kubernetes environment is because upgrading Kubernetes knew about its older versions. It knows how to deal with those older manifests and older manifest versions and resource versions. But when you go backwards in time, Kubernetes doesn't know how to handle those future things that you may have already loaded into it. And so that becomes a problem with downgrading Kubernetes. And so we're not able to support that just because of the nature of the way Kubernetes works. And so that's kind of the basics, and I'm not going to go reset my environment here. And if you do, you'll see everything came up and everything's running just as you would expect it. All right. Now for the next part, I'm actually going to jump over to Windows. Ooh. Looks like my connection fell asleep here. Here we go.
Give it a minute.
There we go. I had to wake it up. So for this, I was not running a VM. This is another machine on my network, and I remote desktoped in. And so we'll take it bigger here. And you can see my remote environment. Let's see if I can, pasting. And so here I've got a kind of remote environment, and I set some things up ahead of time. And in this case, where do I have this? I have it going, but this time instead I have containerd running. And so with containerd, you can do different things. So you use nerdy control instead. And so I can see I don't have anything running. And the reason you don't see anything running here is nerdy control, like Kubernetes has namespaces, also has namespaces. So if I want to see what's running in Kubernetes, I actually just have to tell it the namespace that K3s has everything running in. Then you can see all of this stuff running. Same thing works for other stuff like nerdy control. Yeah, you want me to zoom in?
Yeah, I'm sorry.
Nope, that's all right. I'll zoom in here. Nope. Is it? There we go. So we'll zoom in on each of these, and so you can see. Thank you for reminding me, Robert. I'm not always good with this. And so here we have something running. Now for this case, I wanted to show what it's like to work with internal services. And so I've got something up and running this time. And so if I did Helm LS, you'll see I have WordPress running. It's a pretty simple thing to install and run, but you do have some different components. And I wanted to show what it was like to work with an internal service if I wanted to do something here. And so in this case, I've got it running now. In fact, if I do, you can see I have some different pods running in WordPress. And I really wanted to play around with Maria and just interact with that backend service, right? You've got an internal service that's not exposed outside of the cluster, just exposed as a cluster IP for other things inside to work with. But now you're in a development environment and you want to muck around with that internal service as you test things, make changes, maybe look at its data. And so we have this feature here. It's just on Windows now, but it'll be coming to Linux and Mac in the next minor release, which will be coming here soon. And it's called port forwarding. And as you can see, I've already port forwarded the HTTP. And I know this is small, so we'll come over here and we'll go. And I'm going to go ahead and bring this up. And as you can see, we've got our blog running, right? It's been port forwarded. We're on the other screen. I had to use the port forward commands from terminal to bring it up. I didn't have to here. But here, I want to go muck around with that internal database. And so I can go ahead and I can forward that out. And that will let me start playing around with it. And so I have this tool over here called Beekeeper Studio. And Beekeeper Studio lets you work with databases. And before we got on, I went ahead and I pulled the password and username out, which you can pull out of the secrets in the cluster. But just in the sake of time and sharing that, I didn't. And I can go ahead and we'll test my connection, and it works. Now I can connect to Maria, and I've connected to that backend service because it's exposed to me. And I can go start playing around here. And so we can go look in here. And we'll see if I can make this bigger. I can make this bigger so you can see what's going on inside of this cluster. And we can go to the posts. And I can go look and say, okay, here's the posts we have. And I'll go change around. I see the current one has a title of Hello World. I'm going to go change that to Rancher Desktop, right? And here I've got to apply the change before it goes in. So it made that change, right? And I'm interacting with that backend cluster. So I can come over here and I can refresh it, and it changed it to Hello Rancher Desktop. And I was able to work with and test that backend service just by easily port forwarding something to a local port. And if I go ahead and I cancel it, it takes a minute, and we're working on this. It'll go ahead and cancel that port forward for you. And so that's one of those things that you get in this environment, is that ability to interact with those internal services with the click of a button, which can be useful when you're dealing with something that's just a lot of different parts and you want to look around in those internal parts in a development environment. One of the other things we have here is Wsl integration. And so if you've got Windows Subsystem, you've got Windows Subsystem for Linux, you may have other environments. And in our case, we have other environments. In my case, I've got Ubuntu installed. That's a common environment people have. And so you can go ahead and go muck around in Ubuntu, right? So I can come here and I can do things like, and this will know how to talk to that environment. Now, if it's only in the ones that I select, so if I go ahead and I uncheck this, it takes a moment and it will disable that. So now if I come in, it doesn't know how to talk to it because the configuration's been removed. The idea behind doing it this way was let people only opt into the environments they want. Don't go play in everybody's environment if they don't want us to. And we did it in an opt-in model. And Nerdy Control and the Docker CLI and kubectl and Helm and all of those tools will all work in this environment. So I can use Helm, .ps, ls, and it'll go talk. My current configuration is set that way. And so you can see that that's there. And so you can see Nerdy Control works. You can build, you can do all of those things here. And it'll just work in those opt-in environments. And so this is one of those things you've got in how you can muck around with internal services. And so at this point, I've walked through the primary stuff I wanted to demo. And so I guess the next slide is next steps, right? The next steps here would be, and we can go into questions too. I'm happy to take questions or talk about whatever anybody else wants to at this point.
Ooh, okay. So we actually have some questions. I'm going to go bring them up.
Good.
We have a couple polls out there. I want to give you some of the things. Right now, more people are not currently using Rancher Desktop than they are. So you have an audience of people who haven't seen it or who are not using Rancher Desktop. So that's pretty cool. And the second question was, if you're running Rancher Desktop, what desktop are you using? And vast majority right now, actually more than both Mac and Linux combined, is Windows users. So that's pretty cool.
Yeah, and we try to make that Windows experience work really well. I'm a longtime Mac user in my daily driving for work, and now I use Windows a lot just so I can daily drive like a Windows user. And those same kinds of things that I showed you on Mac, you can do them on Windows today, right? If you're using dev containers and those kinds of things, because with the Docker CLI and the Docker Mobi support, we actually put a real Docker socket where you would expect it. Now, you can have Docker Desktop installed alongside Rancher Desktop, but you can't run them both at the same time because both of us try to put a Docker socket in the same place so that external tools can interact with it, like Visual Studio Code. Visual Studio Code and K3D and a bunch of these tools, they don't talk to the Docker CLI. They communicate directly over that socket connection.
All right. So first question is, when is port forwarding coming to the Mac for Rancher Desktop? And I'll dovetail to the second question.
All right. So that is going to come when we cut the next release. The change has already been merged, and our plan is to get the next release out before the end of February. That's the plan right now. Something would have to pop up to change that. So you should have it before March.
And would port forwarding for Linux users fix the port 8443 issue? From previous conversations, I thought that was the answer, but I just want you to confirm that.
So on Linux, port 80 and 443 are in a range of ports that are they're reserved ports, and you have to have root access in order to grant something the ability to use those ports. It's 1024 and under. And that is ultimately where part of the problem comes in, is how do we bridge that networking to make those ports accessible? And that's one of the things we're still working on. We're not going to get it in that time period. The port forwarding that will automatically generated would be above those reserved ports. So you can still get access to those things and you can easily expose anything. But those ports, if you already have something, say, on a node port and it's above 1024, you'll still see that forwarding should still work. It's those lower ports where we have issues. But the port forwarding here should help you in your development environment.
All right. Next question up is, any plans to create a Rancher Desktop extension for Visual Studio Code that works the same way as the Docker extension? I know there's been a lot of chatter on the internal Slack about this, so I'm going to let you answer this one so I don't misspeak.
So we're trying to work well right now with everybody's external tools. It's a fair amount of work to do this kind of thing. What we would hope to see is a tool that works with Containerd and or Nerdy Control. So that way, Rancher Desktop isn't the only thing that can benefit from it. If we tried to build our own tool that just worked with Docker, we'd be doing a lot of the same work. And so it would really be focused on that Containerd case and that Nerdy Control case. And for that environment, I really think that something great that should be developed is a tool that works for Containerd and Nerdy Control. So whether you're using Rancher Desktop or you're using those tools somewhere else, you can benefit from those tools. And so we aren't really focused on that right now because we've got so many other things to work on and it's just a small team. And I would be happy and desire to promote it if somebody did build those tools for Containerd and Nerdy Control, though.
All right, next question. Rancher Desktop currently installs a single node cluster. Any thoughts on multiple nodes where you can choose number within reason? And this is from Simon. So Simon's one of our prolific people in our community here. So he makes a good point. It's like, sometimes you just might need, an extra node or two.
Yeah, you're absolutely right. And if you go back to that original slide deck that I started with, I talked about Kube Solo as being this environment. Alongside Kube Solo, they had a second one that was Kube something or another that lets you have a multi-node cluster. And so years ago, people identified that was a case. In our situation, we're just including that single node cluster. But there's a but here. You can use K3D, which allows you, you can only do this with the Docker runtime. But we've got K3D, which is a tool out there, and we're already using K3S, and you can use that to install other K3s clusters into your Kubernetes cluster. And so you could say, create a multi-node cluster that using K3D, because that's one of its features is you can deal with multiple nodes. And so the ability to do that is there today as long as you're using the Docker-D runtime and you just use K3D. Now you may be wondering, but you've already got K3s running in that environment. What about that? Well, one of the things, because we know there's some of these other use cases, the ability to turn off our K3s is something that's coming as well. And so if you want to have that multi-node environment, our next step is to be able to turn off our K3s. And then with K3D, you can create a multi-node cluster.
All right. When can we expect good support for VPN like AnyConnect with a Rancher desktop? And I'm not sure the use case to this one. I don't see the use case, but maybe you.
I'm very familiar with this problem. All right. So there's some VPN environments like AnyConnect that push out settings, and particularly on Windows, that conflict with the way the Windows subsystem for Linux does its networking. And that makes it so, well, Windows subsystem for Linux isn't able to do everything that you want it to, which in turn means Rancher Desktop can't. I don't have a timeline on that. What we do have is we have somebody who's actively working the problem. We had somebody recently who was already at SUSE join our team to start working on this problem, who's got a bunch of networking experience. And he's looking at the ins and outs of what do we need to do? How do we solve it in different environments? And how do we deal with the difference between Containerd and Dockerd and that kind of space right now? So we've got somebody who's a recent addition, who's coming up to speed on our code base, how everything works, and the problems in order to do that. So while I can't give a timeline, I can tell you we're working on it. And, we've got ourselves set up so we can use an AnyConnect VPN, and we can start to do this stuff so we can see how it works. And that is currently in flight. I don't have a timetable for how long it'll take to solve the problem. And I'm not a networking guru to really dig into that, but we are working it.
All right, here's the question that might be off topic. I can see that in VS Code, you have used the dev container feature. What do you think about the alternatives, tilt or scaffold in your point of view? Why is it better to dev container other than these alternatives? Might be a little off topic, but if you have the moment to answer.
So it's off topic, but I think it's a good question. I don't have a preference on those tools. The ones that you think are best or the one that fits your workflow, go for it. I chose dev containers because they're, one, really well documented. Two, the manager who's over the team that does a lot of the work. There's a manager who's got most of the team under him, and he's been playing with dev containers and talking to me about it because we've also gotten questions about it. So stuff showed up in our issue queue where people were asking about dev containers, and he started digging into it and how to make it work. And that ultimately is why it turned into something from the demo. It really came out of the community talking about dev containers in our issue queues and in Slack.
Okay.
But I don't have a preference on any of them, and look for the ones that kind of fit your workflow and your style and your needs. Look for the one that fits you the best, because there are a lot of good options out there these days.
All right. And the question of questions, you knew this one was coming. I knew this one was coming. I'm surprised that it didn't get upvoted more. How do you compare Rancher Desktop and Docker Desktop from a technical point of view?
Wow. From a technical point of view, it's really hard to compare the two. And that's because I can't see the source for Docker Desktop. So I can't really dig into what's going on there. They really, if you look at it, Docker went after that. How do we make a great experience of working with containers on your desktop? Build containers, run containers, and that's the core of it. Now they've expanded with other things around that. Docker Compose, and then they went on with Swarm, and they've got services. And I know a lot of people are interested in that basic use case, because that's also the kind of thing that couples with Kubernetes, and where they'd focused on that as their starting point. We focus somewhere else. How do we make a great Kubernetes environment? And we went after the Kubernetes side. What are the needs of a Kubernetes person, a developer who's got to upgrade, test, and those kinds of things? Now, because people want to build those container images, push and pull them, and they want to have this, we now have overlap. And it really comes down to, I think, what kind of model are you doing, and where are you going, and what are your needs with? Obviously, being somebody who started Rancher Desktop and works on it, gonna say, hey, go after Rancher Desktop. And I'm totally biased, completely and utterly biased in it.
No.
But I think it's something to evaluate for yourself, because they've got different strong points and different areas of focus. Well, they do have some overlap there. And I will also say Rancher Desktop's a lot newer. It's been around for just over a year, where Docker Desktop's been around for a lot longer. And so, as somebody brought up earlier, what's going on with VPNs, with things like AnyConnect, they ran into that problem before we did, and they worked out solutions that work for them before we were able to, and we're able to focus on that now. So there's some other differences there that we're continuing to learn about and iterate through and work on to take into account.
All right. One last question. Actually, they say it's one last question, but you know how it goes. When will the quote unquote Docker Compose support going to be added as part of Rancher Desktop? And now I think I could answer this, because I think this actually depends on Container D, but your take.
Okay, so this is going to show me not paying attention the last couple of weeks to some of this. It's one of those things that is near in our mind, and how we handle this, because it deals with Docker plugins, where they need to be installed on the system, and how that works. I know it has been in our backlog, and we've been looking at it. I'm not sure if the support has landed yet. But it is one of those things we do want to get support for in the near future, because it gets around to just how do you deal with Docker CLI plugins, and how does that work? And so, if it hasn't already landed, it'll be coming, because I know people are interested in that.
Okay. All right. We've cleared the questions. I don't have any questions, because I know I talk to you every day, so it's not fair for me. But from the community, we still have about 70 people in the room. Any more questions for Matt, myself, community at large? No. All right. Well, we can wrap this up then. First of all, I want to thank Matt. Matt, thank you for coming. Appreciate you coming and showing us an awesome product that's now GA 1.0.0, or no, 1.0.1 right now. We just had a little minor release, or a little patch in there. We do appreciate your time. And for everybody else in the community, thank you for coming. We do appreciate it. You can join us in the community. When I say community, it's at community.suse.com. You click on the green link below, right below my face, and join the community. Continue the conversation with us. If you have a question, feel free to post it in there. We will get to it. If I don't get to it, someone else will. Usually Simon or Malcolm usually beat me to it most of the times. I feel bad, but join the community. We'd love to hear it. You want to follow me on Twitter? I'm at Robert Sirk. Or you want to follow Matt? He's at Matt Farina on Twitter as well. We'd love to engage with you guys and talk. So until next time, we'll see you guys in the community. Take care.